This is a house circuit, and this is giving a visual depiction of some of the switches and the light bulbs that are attached in there and outlets. And this gives you an idea of, how interconnected it is. When we consider circuits, it's important to, consider, how they're arranged, especially in a house or, in a vehicle or anything that's using electronic devices. How it all connects together affects the entire circuit. And we've seen this picture before, with the aircraft. And it's important to know if something, malfunctions, is it going to affect other things? And so, the series in parallel setup that we have in here, and we have a lot of things in both. It's important to know what is going to survive, what's not going to survive if something fails. For instance, like if radio 2 goes out, is anything else going to go out? Well, fortunately, it's hooked up to this bus in parallel, so nothing is attached in series to it, so nothing will fail. However, if something would happen to this wire, right? The stuff coming off of this, none of this is going to work, right? And so, yeah, so it would be important to know this. I would teach my students during flight training the importance of understanding each part. And, if one thing failed, it's important to know what else would fail. All right, so what we're going to do now, and what I want you to do is to create this circuit on PhET. Again, you can go to Google search PhET, P-H-E-T, circuit, construction, kit, DC only. And go ahead and create this circuit. You're going to place a light bulb here, light bulb here, light bulb here, cell down here, ammeter here, ammeter here, ammeter here. And just watch it. Watch what happens. This is a complex circuit where we have series and parallel together, and that's where we're moving now. So go ahead and pause the clip and build this in PhET so you can visualize that, and then when you're ready, you can hit play to continue. Okay. So with series and parallel circuit, we have to break it down and make it to where, if we had one resistor instead of all of them, what would it be? And so similar in that respect. And then after we're going to do that, we're going to reconstruct the circuit. And so let's say we have, a circuit here with a 7 ohm, and then we have an 11 and 13 in parallel, and then we have an 8 ohm and an 18 volt cell. And we want to find out the overall current and then what's happening in each of these resistors. So as we do that, the very first thing that we can do is start to simplify. We can't simplify it completely, but we can bring these two together. These two are in parallel, but we're going to need to bring those together. So the way we do that, we have to do the 1 over REQ deal. We'll be able to get that. And then next, we can bring them all together because now they're in series. So we have all three of these in series, bring them all together. And then after that, we're going to break it apart. And you can either draw it like that, or if you just want to draw it like that. The key is just drawing a separate picture as you reconstruct. And, it's kind of like a checklist. Well, checklists are really, really important in aviation. And this picture is kind of like a checklist to go, step by step what's happening. And so we're going to reconstruct and then work from there. So the very first thing we'll do is, 1 over 13 plus 1 over 11 equals 1 over REQ. We get those together, and then we can bring them all together. And if we had one resistor instead of all 4 of those, it would be 20.96 ohms. Now, we can apply Ohm's law. V equals IR. We know the voltage. We know the overall resistance, and we have the current, so 0.859. And then if we look at this, as we break it back apart, the current is staying the same in all 3 of these. It's 0.859 amps. And yeah, the current is staying the same. So therefore, what we can find is how much voltage does this use? How much voltage does this use? How much voltage does this use? And if you notice, we just went back one step. This picture is just going back one step, and it's important to do this in a separate section, a separate area, so we don't get this mixed up. So we'll go ahead and do that. So we have for this one 6.01, We have the middle one 5.12, and then for the third one there 6.87 volts. Now as we get into this last one, we think about, okay, what's happening in here? What's happening in here? Now this is in parallel, right? So because it's in parallel, both are going to get full voltage, and the voltage it's going to get is this. This is the voltage used in this spot right here. And so as we break it into the final one, both of them get that full 5.12 volts, and we can determine the current in each of those, 0.47 amps and 0.39 amps. All right, so in this one we have a 3 ohm, and then we have 3 other resistors. Now, a good question asked is, what makes something parallel? Well, things in series are one right after the other. If you know it's in parallel, what happens is the current splits. It splits apart here. So this 3 is in parallel with 5. If we look, here's another split. The 6 and the 10 are split apart, right? So when we're solving parallel and series together, we just gotta bring, just do one step at a time. So, if we look at this one, what's the very first thing that we can do? Well, these 3 are in parallel, and then this one's in series. So if we bring these, if we do that, we can bring those together. So we'll have this, then we'll have those 3 together. And then from there, we're going to bring them all together, and then we're going to reconstruct. So I'm going to give you a chance to try this one. Go ahead and solve the complete circuit. What's the overall current? How much current and voltage is used in each of the things, and that'll be good. So go ahead and pause the clip and give that a try. And when you're ready to check, you can hit play to continue. All right. So for the overall resistance, we should get 2.143. I'm sorry, just for for this one here. Now we have these in series. We're going to add those up, and that's the equivalent resistance. We set up Ohm's law, V equals IR. We get the current. 3.8 amps is the current for the combined circuit. Then as we break them apart, we're just going to go back one step. So in that one step, we're going back. We can figure out how much voltage this uses, how much voltage this uses. So 11.64 for this one, and 8.393 for this one. And now when we do the final step and we're looking at this, right, we know that this voltage, the 8.33 rather, is going to come full 8.33, 8.33, 8.33. And so we can figure out the current in each, and we've got those there. So this is a circuit diagram for a microcontroller to a PC, and you'll recognize some of the things in here. We've got some resistors that you can tell, a diode here, which will only make current go in a certain direction, and you can probably recognize a port here. This is a capacitor, which we didn't have a chance to look at, and the grounding. We've talked about grounding before. And so, yeah, and you can see in here we have things in series and parallel, and there's, in there for different reasons. Okay, so on this one, we're going to set up a circuit, and I'm going to have you solve this one all the way through. We have a 120 volt source, and I want you to find these particular things. What is the overall current? How much voltage does this use? What's the current in here, and what's the voltage use in here? To be able to do this, we're going to break it down just like we did before. And I'm going to let you do that. You can go back once, you're going to go one step at a time. The first thing that you're going to want to do is bring these 2 together first, and then bring them all together in series. But yeah, go ahead and pause the clip and work this one all the way through. See if you can get those values in blue. And let me erase that so you can see better. And yeah, when you're ready to check, you can hit play to continue. Okay, so we can bring those together. 1 over 22 plus 1 over 36, 1 over REQ should get 13.66 ohms for that combination. We bring them all together, all in series. So that 13.66 plus 55 plus 90 is 158.66 ohms with a 120 volt voltage source. 0.7564 amps is the current going through. And so that's the first one. Now we're going to reconstruct, and what do we know is true in all three of these? This is the critical step. This is really, really important. We know that in all of these, the current's the same, right? Current's the same in series, and this is the current, 0.756 amps. And we can find the voltage use in this one, which is another thing that we want, so 41.6 volts. So we've got that. The next step, we can break this one apart, and we know that we've got to figure out what's going on inside here. You know, how much voltage does it use? So 10.332 volts is how much this one uses, and therefore both of these get full voltage because they're in parallel, so they both get the 10.332. And so therefore we can figure out how much current is in this one, and we know the voltage, we know the resistance 36, so 0.287 amps is the current in that one. All right, so for this circuit we have 18 ohms set up here, and then we have some stuff in parallel, but we have an additional thing here where we have a series within a parallel. And so don't let that freak you out, because you know, it's exactly the same thing. It's just one extra step where we have to simplify it. So the very first thing that we're going to need to do is bring these together. We're going to need to bring these together. And when we do that, we have that there. This works just like we did before. We just have one additional picture. So as we reconstruct it, we're going to go again back one picture at a time and work through that. So why don't you go ahead and pause the clip and go as far as you can. Try to figure out you know, the current and voltage in each part. And when you're ready to check, you can hit play to continue. I really want you to try this on your own. See if you can continue with that pattern and follow that logic of what's going on in series and parallel to solve this one. So go ahead and pause the clip and give this a try. When you're ready to check, hit play to continue. All right, so we've got the 18 there, and then to bring these all together, it's going to be 1 over 18 plus 1 over 11, which is this, plus 1 over 8 equals 1 over REQ, and that comes out to 3.68 for this one. When we bring them all together, 21.68, you know, of 18, adding that to this, so that would be, if we have one resistor instead of all, how many are there? 5 of them. Then that's what we would have there. We apply Ohm's law, so we have 50 volts, 21.68 ohms, and we can find the current, and the current's 2.31 amps. Now, as we reconstruct, right, we just go back one step at a time. And so if we consider this, right, the series, we know that the current is this. So when we go back one step, the current is 2.31 amps. We can figure out how much voltage this uses. We can figure out how much voltage this uses. So the 18 ohm resistor is using 41.5 volts. And then this all together is using 8.5 volts. Now, the next thing that we're going to do is just go back one more step. And so as we do that, we know all three of these are going to get 8.5 volts. Now, if you notice, we've left this all together still, because this is the step that we went back to. So just one step back at a time. You know, this is getting a full 8.5. The middle one's getting a full 8.5. The bottom one's a full 8.5. All of them get a full 8.5 volts, because that's how much this one uses, right? Now, the very final step is when we zoom in here. We're zooming into here. This is the final step. And we know in series the current stays the same. So that 0.47 is the same in both of these. Therefore, we can figure out how much voltage each uses. So the one on the right is going to use 2.35 volts. The one on the left is going to use 6.14 volts.